Assalamualaikum and very good morning class. In this PowerPoint, we will continue with more examples on finding Fourier series equations for some waveform. The example 5 shows a sawtooth wave signal ft with amplitude of 10 and time interval equals 2 pi. The question is, find the trigonometric Fourier series of the following sawtooth periodic function. To solve this example, let us start with some fundamentals for the signal. Time interval of the signal t equal 2 pi. Ft is neither even nor odd function. The analytical equation is Ft equal 5 over pi omega t for omega t from 0 to 2 pi. The periodic function equation Ft equal Ft plus 2 pi. Now let us compute the coefficient A0. Using the equation, the average value A0 equal 1 over t integral 0 to t ft dt. Substitute the equation for ft. We have A0 equal 1 over 2 pi integral of 0 to 2 pi 5 over pi omega t d omega t. Continue with the integration. We have A0 equal 5 over 2 pi square times omega t square over 2 for 0 to 2 pi. And finally, we have A0 equal 5. Next is to find the coefficient An. Based on the equation, An equal 1 over pi integral 0 to t ft cos n omega t d omega t. Putting the equation for this example, An equal 1 over pi integral of 0 to 2 pi 5 over pi omega t cos n omega t d omega t. Based on the equation, we have to do integration by part where integral u dv equal uv minus integral v du. In this example, let u equal 5 over pi omega t. Therefore, du d omega t equal 5 pi. Integral dv equal integral cos n omega t d omega t. Therefore, we have v equal sin n omega t over n. Continue with the integration. We have An equal 1 over pi times 5 over pi omega t times sin n omega t over n for 0 to 2 pi minus integral 0 to 2 pi sin n omega t over n times 5 over pi d omega t. Solving this equation, we have finally An equal minus 5 over n pi squared times minus cos n 2 pi plus cos 0. Refer to the red box that I include in the slide and substitute the values. Finally, we have our An equal 0. Now, let us proceed with coefficient Bn. Based on the equation, Bn equal 2 over t integral 0 to t ft sin n omega t d omega t. Putting the equation for this signal, we have Bn equal 1 over pi integral of 0 to 2 pi 5 over pi omega t sine n omega t d omega t. We have to do integration by part. Let u equal 5 over pi omega t. Our du over d omega t equal 5 over pi. And our integral dv equal integral sine n omega t d omega t. And therefore, v equal minus cos n omega t over n. Let us proceed with the integration by part to calculate Bn. And we have Bn equal 1 over pi times 5 over pi omega t times minus cos n omega t over n for 0 to 2 pi minus 1 over pi integral of 0 to 2 pi minus cos n omega t over n times 5 over pi d omega t. Next, we proceed with putting the values for the integration. And finally, we have coefficient Bn equal minus 10 over n pi. The general form for Fourier series obtained equal ft equal 5 plus summation of n equal to 1 to infinity minus 10 over n pi times sine n omega t. Alternatively, the Fourier series expansion is given as ft equal 5 plus minus 10 over pi sine omega t minus 10 over 2 pi sine 2 omega t minus 10 over 3 pi sine 3 omega t plus triple dot. In example 6, we have to find the trigonometric Fourier series of the following triangle function. To start with the fundamental, time interval t equal to pi, fundamental frequency omega equal to pi over t, which is 1. Fx is an even function, therefore Bn equal to 0, and it is symmetry. We have to find equation for the signal from 0 to pi. The analytical equation Fx equal 1 minus 2x over pi for x from 0 to pi. The periodic equation Ft equal Ft plus 2 pi. The average value A0 equal 2 times 1 over pi integral 0 to pi fx dx. Rewrite the equation A0 equal 2 over pi integral 0 to pi 1 minus 2x over pi dx. Notice that since we use the interval between 0 to pi, therefore the equation has to be multiplied by 2. Continue with the integration. We have A0 equal 2 over pi times x minus x squared over n for 0 to pi. Finally, we have A0 for this signal equal 0. Next is to find the coefficient An. We have the equation An equal 2 times 1 over pi integral 0 t over 2 ft cos n omega x dx. We proceed with the equation. We have An equal 2 over pi integral 0 to pi 1 minus 2x over pi cos nx dx. We do the expansion. an equal 2 over pi integral 0 to pi cos nx dx minus 4 over pi square integral 0 to pi x cos nx dx. When we do the integration, we have an equal 2 over n pi sin nx for 0 to pi for the first term, minus 4 over pi square integral 0 to pi x cos nx dx. We have to do the integration by part for the second term. Let u equal to x, du equal to dx, integral dv equal integral cos nx dx, v equal sin nx over n. Proceed with integration by part. We have an equal to 0 for the first term since sin nx equal to 0 for all n. For the second term, we have minus 4 over pi square times x sin nx over n for 0 to pi minus integral 0 to pi sin nx over n dx. We simplify the equation. An equal minus 4 over n square pi square cos nx for 0 to pi. And if we substitute the 0 and pi, we have an equal 4 over n square pi square times 1 minus cos n pi. To expand the Fourier series, an equal 4 over n square pi square times 1 minus cos n pi for all values of n, we refer to the red box on the slide shown here. For n equal to odd, an equal 4 over n square pi square 1 minus negative 1, an equal 8 over n square pi square. For n equal even, an equal 4 over n square pi square times 1 minus 1, which is 0. If we find the coefficients up to 7 harmonics, we have a1 equal 8 over pi square, a3 equal 8 over 3 square pi square, a5 equal 8 over 5 square pi square, a7 equal 8 over 7 square pi square. Hence, the Fourier series can be expanded as fx equal 8 over pi square cos x plus 8 over 3 square pi square sin 3x plus 8 over 5 square pi square sin 5x plus 8 over 7 square pi square sin 7x plus triple dot, or fx equal summation of n equal to odd to infinity 8 over n square pi square sin nx. Next is to find the coefficient an, which is equal 1 over pi integral minus pi to pi fx cos nx dx. We have an equal 1 over pi integral minus pi to pi x squared cos nx dx. We have to do the integration by part. Let u equal to x squared, du equal to x dx. Let integral dv equal integral cos nx dx. V equal sin nx over n. So therefore our n will be 1 over pi times x squared sin nx over n for minus pi to pi. And the second term is minus integral minus pi to pi sin nx over n 2x dx. If you substitute the value, we have the first term will be 0. Therefore, an equal 1 over pi times minus integral minus pi to pi sin nx over n 2x dx. If we rewrite the an, we have an equal minus 2 over n pi integral minus pi to pi x sin nx dx. We have to do integration by part one more time. So if you let u equal to x, du equal to dx, integral dv equal integral sin nx dx, v will be minus cos nx over n. So our an will be minus 2 over n pi times x minus cos nx over n for minus pi to pi plus integral minus pi to pi cos nx over n dx. We do the integration and the second term will be 0. Therefore, finally, we have an equal 4 over n squared cos n pi. That's all for this PowerPoint. In next slide, we will learn about exponential Fourier series. Thank you.